Okay. We're going to go back to some solution stoichiometry, and I'm going to hand you out some things that you are going to be cutting out. Actually, yeah, let's go ahead and do that. So the way this is designed is there's like a slash mark here. You're going to fold on that slash mark. And then when you do that, you can cut the box in half. Don't cut out the gray, the dark gray. That's where you tape. So we need to cut out these boxes that have the dotted lines. And you can do it however you want, but what I've set up on here is that if you fold it on that straight line going through here, that's exactly in the middle, and you can just and you're going to need to tape this down to some kind of paper. This can be in your notebook, or if you want a free paper, that's fine. Two things that say slider, you don't need to cut out those boxes. Those are going to be the labels that will show in the holes. All right, and we are going to end up doing lots of different kinds of stoichiometry, but for right now, we're just going to focus on the solution stuff. So to keep things straight, this will allow you to do all the different kinds, but to keep things straight, you should have a highlighter in one of those baskets there. Highlight where it says solution, and then volume A in milliliters. And then the middle box on the bottom there that has molarity. And then on slider B, there are two things we said we could find. We could find the concentration, or we could find the volume of the solution. That pen's kind of dark, so I'm just underlining. And so those would have units of moles per liter if it was the concentration, or milliliters if it was the volume. And so the middle two boxes on the bottom. Okay, so once you've got things cut out, highlighted, then you should be able to tuck these in underneath. And they slide so that depending on what the question is, you can move it to the appropriate thing for that question. But we're going to do everything in your highlighted color as well. All right, so as an example, we have 17.51 milliliters of 0.185 molar NaOH, and they are required to neutralize 15 milliliters of H2CO4. And we want to know the concentration of H2CO4. So we need an equation. So what are the two reactants in this equation? Sodium hydroxide, the H2C2O4. This is oxalic acid. You don't need to know that name. All right. So to balance it, it's good to know what the products are. And so for a neutralization, which this is an acid, which I can tell because it's got an H out front, and a base because it has the OH. That's a neutralization. My products are going to be water. And they're going to be the combination of the other ions, the Na and the C2O4. So it'll be Na2C2O4. So this tells me that I'm not balanced yet because I have two sodiums over here. Okay. So I'm going to need to put two sodiums there. All right. So are we otherwise balanced? So remember we said ions, we can kind of take as a whole. So I have one of these here and one of these here. So that's balanced. And that leaves me with two OHs and two H pluses. So how many waters am I going to end up with? Two. So the important part of this is for our stoichiometry, we need to be paying attention to the 2-to-1 ratio between these two things. Okay. I like to list underneath each chemical what we know about them so I don't get them mixed up. So for the sodium hydroxide, I know that it is 17.51 milliliters, and I know that it is 0.185 molar, and that's moles per liter. And then for the oxalic acid, I know that it is 15 milliliters. And then the question is asking me what this is. Okay. Got all that information sorted out. And so now I'm going to go to my slider and see what I can do. Which one is the no? The sodium hydroxide or the oxalic acid? The sodium hydroxide. I know that because I have two pieces of information here. I have more information here. So this is A. I have a solution for A. I have the volume. I'm going to take that volume and multiply it by what's in this box, the molarity divided by 1,000. Okay. So that's my first step. I'm going to take 17.51 times 0.185. So this is milliliters. This is moles per liter. And then I'm also going to take out the liters with milliliters. So I'm going to have 1 liter up top and 1,000 milliliters at the bottom. So that's what these two boxes are telling me to do. Multiply those. Okay, that, I'll put my book. That should give me 0.00324. I need to figure out what units I have here. So I've got liters on top, liters on bottom, they cancel. Milliliters on top, milliliters on bottom, they cancel. So this is moles. And then what chemical am I talking about? NaOH. Okay, so this is what these two boxes told me to do. Multiply those two things together. Step 2 is down here. This is my stoichiometric ratio. So I'm going to have moles of A on the bottom and moles of B on the top. And where do I get A and B from? That's why we had to balance the chemical equation, right? So the numbers are going to come from here and here. So I'm going to take this number, that's going to be the beginning part of step 2, 0.00324 moles of NaOH times, from my equation, 2 moles of NaOH on the bottom, 1 mole of oxalic acid on top, squeezing that in there. Um, 162, 162. Okay. So I've gotten rid of sodium hydroxide and I'm left with moles of oxalic acid. Okay. So my next thing on here, continuing from right to left, is I'm going to take whatever the result was here, and then I need to find what this is asking for. So right now I'm on volume. Is that what this is asking for? No. So I'm going to move my slider until I see concentration. I can get it to come through past the tape. Now it's on concentration. And so for concentration, it says I need to divide by the volume in liters. And the way I can do that is by multiplying by 1,000 on top. So I'm going to take this number 0.00162 and divide it by the volume in liters. The volume of the thing that I'm looking for, volume of B. So 0.00162 moles of H2C2O4 times, this volume was 15 milliliters. Make that liters. I have to put 1,000 milliliters per liter on top. And so that's going to cancel those, and I'm going to have moles per liter. Okay. And that should give me 0.108. I still have moles left over. And I still have a per liter left over. And this is my B, my unknown H2CO4. All right, so we're going to try another one. We're going to use our calcium and silver equation from the pool. So I'm going to rewrite it. CaCl2 plus 2AgNO3 gives me, I think that was 2AgCl plus Ca2 plus NO3 minus. Okay, so now our question is, what volume of silver nitrate reacts completely with 5.25 milliliters of calcium chloride? So I have 5.25 milliliters here. I have 0.100 molar, but I don't know the volume. And I have 0.250 molar. So this is what I'm looking for. So which one is my known? CaCl2. Okay, so that's the one I start with. So always start the same way with solution stoichiometry. So the slider A only has one position for solutions. So that says I take my volume in milliliters, and I always recommend start with a thing that only has one unit. So milliliters is 1 unit, molarity is 2. It's moles and liters. So I'm going to start with milliliters, 5.25 milliliters. And then it says we're going to multiply that by, it's got M over 1,000. So M is the 0.250 right here. That's moles per liter. And then we're going to divide by 1,000 milliliters per liter. And this is all the calcium chloride. I'll label that. We got 2 chemicals we're thinking about. So milliliters cancels here. Liters cancels here. I'll be left with moles. So 5.25 times 0.25 divided by 1,000. And this is 0.00131. Is that appropriate sig figs? Yeah, I have 3 here, 3 here, and this is infinite sig figs because it's a conversion within the metric system. Okay, my units here are moles. Have I switched chemicals yet? No, I'm still on calcium chloride. Step 2, now I'm at the boxes at the bottom, or the box at the bottom. That's my stoichiometric factor or my mole to mole ratio. So 0.00131 moles of calcium chloride times, I want moles of CaCl2 on the bottom, moles of my unknown on top. Now, once we get beyond solutions, they're not always going to be reactants. Sometimes one will be a reactant and one will be a product. Sometimes the known will be the product, sometimes the unknown will be the product. So you need to pay attention to which one is the question asking about. The one that goes here is what I'm trying to find information about. So that's my silver nitrate. Okay, and then what number goes on the top? 2, because that's the coefficient here. And then here I have my invisible 1. Okay. And now my moles of calcium chloride cancel out, and that's why it's important to have the chemicals there. So I know I'm no longer talking about calcium chloride. I've moved on, and I'm talking about silver nitrate. Okay. Then my next step, I'm going to check. I want to be at volume. Questions asked about volume. So I'm going to move my slider until I can see volume. And it tells me I'm going to multiply by 1,000 milliliters. That's going to give me back in milliliters. And I'm going to divide by the molarity of B. And B is my unknown. That's this guy. So 0.00262 moles of AgNO3 times 1,000 milliliters per liter divided by the molarity, 0.100 moles per liter. So I have per liter and per liter I can cancel. Okay, I have moles. I can cancel here and here, and that leaves me with milliliters. So I divide by 0.1. And I end up with, oh, and I forgot to multiply by 1,000. I end up with 26.3 milliliters, because that's the only unit left, of AgNO3. Okay. So you don't have to use this slider. I think once we have more ways that we are doing stoichiometry, it will be helpful to sort out which method am I using, because people sometimes mix up solutions with grants. All right. On Wednesday, we will be talking reaction types and combinations, predicting combinations of ions as products.